Alrighty, good afternoon, everyone. All right, so just a quick introduction. I'm Gokila Dorai. I'm one of the assistant professors from the neighboring building, so Augusta University. I'm coming from the School of Computer and Cyber Sciences. I also serve as the director for Access, Success, and Belonging, which was originally called something else. Okay. All right. So I would like to know what's the energy level of our audience. Are you tired? Are you still fresh? Do you want a long talk, a crisp talk? What would you like? What's that? Okay.
I'm kind of awake, very
Really?
but I do a lot of the same digital and forensic work.
Excellent. Excellent.
Kind of interesting to hearing about it with AI. And of course, you've got some collaboration on criminal investigation. I do a lot of the civil stuff.
Okay. Okay.
So I'm interested to hear
Wonderful.
proposing on the criminal stuff.
Wonderful, wonderful. And those of you from the law enforcement side, may I know if there's anyone in the audience? Okay. Alrighty, wonderful. And thank you so much for being here. I know this is a late afternoon session, but I really appreciate your presence. Okay, great. Wonderful. So the topic today we're going to be discussing on harnessing the power of artificial intelligence for digital forensics. Digital forensics, just to give you a brief about it. So what we tend to do there is, if you have your mobile phone or if you have a computer, a PC, laptop, a workstation, and if there's any type of potential evidence that's stored in one of those devices, technically the law enforcement would be able to seize that device and they would be able to search for that evidentiary information from those devices. This is typically conducted in a forensic lab, and it is driven by a search warrant. Okay, so this is the entire process of digital forensics. Now it's an ocean, so it is not just limited to mobile devices. It is not limited to a computer, but there's much more behind it. So there could be network forensics, there could be cloud forensics, it could be a car forensics. Okay, so it could be a drone forensics. So it's vast. Okay, all right. Alrighty. So the agenda for today, I'm going to be discussing a little bit about the lab, my laboratory that I founded and I'm directing. I'm also going to be talking about some of the collaborative activities that I've been doing with different state, federal, and local law enforcement agencies. I'm also going to be talking about a brief 3 different research projects that I'm working on, and I'm advising 4 different PhD students at the moment. And they have been producing some exciting research work. Okay, all right. Now here you go. So this is the lab that I founded. It's called the Digital Forensics and Artificial Intelligence Research Lab. This was launched roughly a couple of years ago, and my PhD dissertation was primarily funded by the National Institute of Justice. So it has a lot to do with digital forensics and how we can smartly analyze data and pull data out of your systems. Okay. All right. And in my lab, we also look into 2 more, upcoming, I would say, like things of interest. One is Internet of Things type of devices and what type of data could be obtained from such devices, how privacy and security measures are lacking in some of the upcoming fields. So these are the other areas that we are investigating. Okay, so here are some existing collaborations. We have been partnering with the Georgia Bureau of Investigation, several of my frameworks. We try to get some early feedback about our projects, about our thoughts, like trying to implement a few things. So we first discuss with them, try to get their feedback, and get to see whether these are some practical tools that would be later used by law enforcement agencies. And similarly, Florida Department of Law Enforcement, they evaluated my dissertation, and National Institute of Justice and Augusta University Police Department is currently another agency we are working with, and we are trying to learn more about their requirements and needs. Okay. Perfect. So the first area we're going to discuss here is digital forensics research and how artificial intelligence is used here. quick question to the audience. So when I talk about AI, right? So how many of you are thinking about, huge facilities like FBI, headquarters, where you have multiple images, multiple photographs, they're trying to discover, like a specific human being or a specific object. So what's the AI that's actually flowing in your head right now? Computer vision? Uh-huh.
Mostly language models.
Okay. All right. Machine learning in general. Okay. So I do little bit of computer vision, but I do more of the natural language and the text-based processing. So I'm setting the tone very clear, so that's what you're going to be expecting in the rest of the slides. All right. Great. So the first project that we are going to look into is called the Targeted Data Extraction System. In short, I'm going to call that TDES. Okay. Now, here you go. What does this picture remind you about? Exactly. Rust shooting incident. And what was typical about this case, right? So Alec Baldwin accidentally pulled the trigger, and Elena Hutchinson, she lost her life. Where does AI fit into this case? Is AI even being used in this case? I don't know. God knows. Prosecutors knows. Okay. But how AI could solve a case like this is what we are trying to get into in the next few slides. Okay. So one of the things that was raised from Alec Baldwin's side is, even though law enforcement had access to his data, that is his mobile phone that was seized, right? Is it okay for law enforcement to look into all of the data? If, let's say, you or I happen to be one of those people who have to give up all of the data from our mobile phone just because we have some data related to that case, or we may or may not have some data related to that case, right? So how would you feel, especially if you're a bystander or if you happen to be a victim? How would you feel about it? You feel it's an unnecessary privacy invasion, right? But currently, the tools that we have, the way it works is, as soon as law enforcement gets hold of a mobile device, they tend to image the entire device, right? So people who are working with it certainly know that the process of imaging a device is nothing but you make a bit-by-bit copy of every single information from the mobile phone, right? Is it necessary if just an email or just a single picture or a photograph is all that we are concerned about? So that is where AI is actually coming into picture. So what we are trying to do here is, so for example, what you get to see at the bottom of the slide is a set of tools that are technically used, like practical set of tools, commercially available tools that law enforcement agencies use. So such tools are Cellebrite, Oxygen, FTK, whatever they have access to. And they are heavily licensed tools. Like, for example, per license could cost anywhere between 5,000 to 50,000 rupees, okay? $50,000. So that's what we are looking at. So the solutions that we are proposing here do not involve JTAG, chip-off. We are not trying to image the entire device. But what we are trying to do here is, if we have to think from a victim or a bystander perspective, and if there are privacy concerns, the US Fourth Amendment, constitutional rights that kick in for a case like this, then the approach that we are offering here would be viable. So what we are trying to offer here is, if we know when the incident happened, where the incident happened, and what is the nature of the incident, who were involved in that incident, we already have a bunch of information about that incident, right? So all this information put together, it's translated into what is called as a metadata of a data, okay? So a data is nothing but a picture that you have taken in your phone. It could be an email that you had actually sent to someone, or it could be a message that you received via text, right? So all this is data. Certainly you know when the incident or when this specific data was shared or taken or stored. So you already have the answer for the critical question about when it happened. So it is linked to the date and time of the information. Okay? And then where did the information or where did the data actually was taken? So that's the location. So that's the second type of metadata that we have. GPS, if it's on all the time, then you certainly have your location services available, and every single information that you have, like a photograph, it's getting tagged with that information. Okay, so this is the second type of information. Now, automatically, the way that iPhones work or Android devices work, you can just imagine a bunch of imaginary databases hanging around your head. So it's a bunch of SQL files. And what is available in those SQL files is you have connectivity between various databases. So you can just translate this whole picture into a bunch of applications that are running on your mobile phone applications, right? So for example, if you have 3 different applications, Facebook, the contacts application from your phone, your photos or the albums that you have in your phone, now every single mobile application is sandboxed. So every single mobile application has a database associated with it. Okay? It is structured in a way to store all of the 4 information, that is date and time of what data is flowing in, the location if it's associated with the data, the contact information with whom you're sharing, okay, as well as any other special category of information. So the special category of information is where really our artificial intelligence or machine learning models kick in. Okay, so what is the type of special category of information, right? So if you happen to take a photograph of this room, obviously it's filled with a bunch of chairs, a bunch of people, there's a table, there's a television, there's a monitor, like there are many things associated with it. There are a bunch of lamps. So every single item that's present in a photograph, it's actually a content, right? So this is all, every single object is now being identified using machine learning models. So this is plain old object detection. So this is where computer vision really kicks in. Now, okay, so all this is known information, so what's novel about it, right? So what we built is an application. It is capable of running on a computer. It is also capable of running on a mobile phone. So this application, it leverages all of this information, and it is able to narrow down to a very specific set of information. So instead of having to pull everything off of a mobile phone or a computer from, a victim or a bystander, or in some cases even a suspect, if we have to narrow down to some information, here you go. So this is the solution, right? So use a combination of metadata filtering and content filtering. That is what information could be contained in it, right? Okay. So do we have any questions here?
So you're trying to,
Yeah, go ahead.
so you were trying to make the case for the AI to somehow kind of narrow your extraction efforts.
Yes, yes. And it's not just AI, it's driven by the metadata first, and then comes the content. Yeah.
Well, I'll share a couple problems with you. Maybe you have a solution. One, this whole case is going to go through, say, discovery in about two years of tough lawyer haggling. You never know where they're taking you. So a lot of times these cases, you start off with one idea, and you got to go back to the initial stuff.
Yes.
Because they've taken it to a totally different
Yes.
idea. And then two, the ideas about the date stamps and stuff like that. There are a lot of things that don't have the date stamps. You're not able to filter them that way. Particularly, if people are doing stuff and they're sending it through with social media, for example, that now becomes kind of evidence after the fact. Social media has a tendency to scrub all the metadata, so you don't have a way to filter that, even though that might be a video or a picture through Snapchat or something like that. Behold, that becomes very useful. 2 years down the line, once all the lawyers figure out what the real case is going to be about.
Right.
So it's a nice idea. I think you have those kind of problems that you've got to resolve.
Yes, that's right.
Because otherwise, I think you always have to do the full extraction. I just tell people that, look, I got too much data to look at. I'm not interested in all the rest of the stuff. I'm focusing on this. And it's just what I have to do just to get it all, because I don't know where this is going on, until 2 years down the line.
I completely acknowledge most of the limitations that you are, most of the limitations that you're talking about. But if it is driven by consent, so the consent already will list these things out. So the consent comes from a victim or a bystander. Now, if it is driven by a search warrant, obviously you have access to all of the data. The caveat here is how much of a burden we are trying to reduce for the analyst, and how much of reasoning we can produce if we are trying to narrow down, and how much of explainability we can actually give to accept AI in such a field. So these are three different things. It is still getting there. So we have a patent on this technology, and this framework has been evaluated by the National Institute of Justice for over 3 years. So the tool is actually available as well. I believe they may have hosted it in NIST, so National Institute of Standards and Technology. Now, go ahead, please.
I certainly agree from an analytical standpoint.
Yes.
After you've done the extraction, that yes, doing something like this to help you read through all that stuff, because there are gobs of data out there. That part would be good. But in terms of trying to save you, or for privacy reasons, from extracting everything, I think you're...
So what we have done here is we have tried to extract and mask the information. So it will be kept in an unreadable format, even for the law enforcement officers to see, except for whatever we have to release. So it is purely driven by a narrow down search rather than a broad search of everything. So I think one of the cases, 2015, it doesn't strike me immediately, but courts have opined how much data could be extracted from mobile phones. So these days, if there's a search warrant given by an officer, I don't think judges, magistrates blindly sign them, so they review it. And if they're asking for all of the information, they are trying to restrict or at least put some restrictions there to ask, hey, okay, so this is the probable cause, this is what they are requesting, this is what I'm going to approve. Otherwise, some of the search warrants are getting thrown away. So this is slowly, the model is changing. In some places, there are e-discovery models. In some places, there are e-search warrants. So there are better practices coming into place. And if there are better practices, what it means is it gives us more leverage to identify all of the 4 or 5 information. And with respect to scrubbing the data from social media posts, it is something that I think everyone has a challenge with. So let's just focus on how mobile phones could be leveraged here and how information could be computers or mobile phones wherever the metadata is available. Yeah.
So, sorry to walk in late, but to your point,
you're fine.
A photo of this. So would you, from the metadata extraction, be able to tell if somebody deleted people from the photos, edited the photos, removed them?
Yes. So at least not in this model, but yes. If it's an extensible model, which certainly it could be extended, so we can look for obscure data, if something was intentionally modified, if something was deleted. So file carving techniques obviously are available. Now, most of the commercial tools that law enforcement are using with already come with that ability. It's just that how machine learning is infused into that tool is still at a naive stage. So Cellebrite has implemented things, Magnet, artificial intelligence forensics, so they have introduced few things, mostly related to CSAM cases, mostly related to discovery of information where there's a bulk amount of information, but they want to narrow down based on some text or based on some object, right? Okay. All right. Let me skip this slide. So this is a literature review, not required. Okay. Now, how can this be extended, right? So this can be extended to, let's say, a mass incident, a mass shooting incident somewhere where many people, several people have actually taken photographs or videos or have exchanged texts. Now, if all of them are able to exchange data with law enforcement using a crowdsourcing model, you now have a bunch of information. You now have a bunch of metadata. So stitching everything together, that can help us narrow down to what the incident has to discover. Okay? All right. Yeah. So what this primarily brought us to, when we compared our tool with commercial tool, it did bring down the amount of processing time at a very high pace. So for example, we did not extract all the information, right? So when we had just a limited set of information, all we had to pick was the related files. So typically commercial forensic tools, since they pull all of the information, including thumbnails to associated files to everything, the processing time is also high, the extraction time is high, and then, of course, there's a lot of data available for law enforcement to analyze. So where are we headed to? For example, where law enforcement had to just look into, let's say, 50 gigabytes of data 5 years ago, they are now looking at 512 gigabytes of data that's just coming from a mobile phone, because exponentially, or at a very fast pace, the storage ability of these handheld devices is increasing year by year. So whatever we can discard at an early stage, it's better to discard. Now, what does this end up in? So the risk of identifying exculpatory evidence is another problem. So anything that we try to think from the perspective of, hey, I want to find out whether this is the evidence, this is the person, okay, so I have been able to find out. Now, if there's a possibility of exonerating the person, then that is something that's questionable whether this tool is able to do or not, right? Because we are already narrowing down the search based on some criteria. All right, good. So just a brief about the journey. So 2019, a prototype was delivered to NIJ, and then we had a patent issued, and then final report, and it took a bunch of years for assessment. And slowly, this project evolved into an NSF-funded project. So National Science Foundation gave us a grant to implement a socio-technical framework. So this is something that has been going on for the last 3 years. We have another half a year to complete the work. So towards this, what we have done is we have implemented 3 different parts. That is a socio-technical framework that was built on top of the targeted data extraction system I was just talking about, along with blockchain, along with natural language processing. So what this empowered us to do was, if somewhere something was to happen that intentionally some data was hacked, let's say from the time of the search, from the time of the seizure of a device to the time of the analysis of data, we'll be able to have accurate traceable patterns using blockchain. So the speaker right before me, Dr. Hoda Maliki, is one of the co-PIs on that grant, and I'm the lead PI on the grant, so we are able to do a collaborative work extending it to offer blockchain-based data provenance. So throughout this trail, with proper chain of custody, if anything was to be deleted, or if anything was to be intentionally modified or hacked into, you're able to catch that. Okay? All right. Okie dokie. So here you go. One significant contribution in the last 1 year is we were able to introduce what's called as a zero-shot classifier. Okay. So for the non-AI background audience, what exactly is zero-shot classifier, right? You all know that for machine learning models to work, there are 2 parts to it. You first tell your algorithm or your computer what data is contained, okay? And then you train a program to understand the data patterns. And then as you introduce new data, the algorithm can classify based on the information it already knows, right? Now, let's say I want to try something out on every single one of your mobile phones. One of you may be interested in photography. One of you may be interested in news. One of you may be interested in sports. So varying amount of data, right? And the information is new. Every time law enforcement happens to process a device, it's new type of information. Maybe the type is the same. That is, it's either a photograph or it's text. But what is contained in it every time is new. So zero-shot classifier is basically one solution where if we have unknown data patterns, if we do not know what the data is going to contain, it can actually cluster the data. And it is capable of identifying new data without the training data containing such type of data. So that's as simple as the zero-shot classifier. And this is something that was helpful for us to analyze huge amounts of data, especially if they are text-based. So this applies to 2 different types of texts. One is if they are large texts. So an email could be short or could be large or long. Or it could be social media text, right? So there are different types of text. The toughest scenario here is if it's a short text. We don't have that good machine learning models yet to classify, to analyze, to understand unknown patterns in short textual information. Okay? It could be as simple as a Twitter feed. It could be something like your SMS. It could be something like a group chat. But the way these machine learning models are trained, if you have a large corpus of text, like a library, like a journal, like a paper, research paper, like a sports news, etc., then it can perform well. So our implementation here that uses a combination of clustering, medioids, as well as embeddings was able to give us good results. And here you go. Okay. And here's a snapshot of our algorithm. Trying not to go too much into the details, except that I'm going to tell you that the clustering technique that was behind this is the agglomerative hierarchical clustering. So you can imagine that to be a huge amount of corpus. And if you have 30 or 40 identified topics there, it could be sports, health, fitness, politics, entertainment, movies. So these are different set of topics, right? What human beings would converse on a day-to-day basis. So we have about 30 to 40 such topics identified. We have used Yahoo, Reuters, we have used Facebook, we have used data from various different models, like training data. We have pulled everything together, and then we have applied clustering as well as tested the predictions. So it has been refined over and over, and we just got an acceptance on this paper. So this is going to be available from the International Conference on Digital Forensics. So it's called ICDF2C. If anyone happens to be there in Croatia this year, then this paper is going to be presented there. Okay. All right. Okay. So how did the preliminary results look like? I think, okay. I need to go back a little bit here. Okay. All right. So compared to decision tree, random forest, SVM, we did see that the zero-shot method at least gave us good results, good true positives, and it did avoid some of the false negatives. So some of our results happened to be promising, and it was tested on 3 different data sets, one from Google, Facebook, and we also applied some transfer learning. Okay. All right. This was primarily implemented by one of our postdoctoral students. And here you go. Some more results available in the paper. Now, what did this bring us to? The current phase at which we have our project is we are looking into huge data sets of search warrants, primarily coming from the state of Utah. So we are trying to understand the privacy implications, and we are trying to understand how broad or narrow these search warrants are. Now, we do not have search warrants that were thrown away. We do not have rejected search of warrants. So everything that we have are approved warrants, okay, close to 50,000-ish. We are having large language models study these things. So we are having models that are trained specifically to identify the privacy implications from these warrants. And we are hoping that it will have a significant breakthrough sometime in the future about how officers write search warrants and how judges or magistrates are granting approval for these warrants. Okay. All right. Okay. So the second set of research questions we'll be talking about is mobile commerce and how digital forensics can actually play a role here in mobile commerce, right? So how many of you use applications like Amazon, Etsy? Yeah, all of them, right? 100%, yes. Okay. How many of you let your kids use these applications? Yeah. Okay. All right. You don't have one, so Good. All right, good. So what we have discussed here is from the dirty list. All these applications have been listed to contain stuff they should not contain. So typically CSAM type of materials. Okay. Amazon and Etsy, two quite popular mobile commerce platforms, applications have also been listed here. So it just made me curious to go dig deeper into these applications, conduct a thorough mobile forensic analysis, and identify whether it's true what type of artifacts these applications really do leave behind. Like what residual data can you find from using those applications. Now, both these applications have a huge user base, and they have been under scrutiny a few times by parents, by the society, for having some listings without properly moderating those listings. So what do I mean by listings? So for example, if a seller wants to sell something on a platform like Etsy, they take pictures of that item, they can just post those items onto the platform, and it becomes available to any consumer to view such items, right? So they are called listings. Those listings are not being moderated by both Amazon and Etsy. So what typically tends to show up is, for example, if the search is something like gift for stepdaughter, okay, it happens to bring up pictures that could be disturbing, okay? So some search terms brought us even more disturbing facts, right? And the model that we followed here is we did these experiments with a bunch of mobile phones. We tried to understand what's actually left behind. To our surprise, some of the listings and some of our search history, I think most of our search history, in fact, was kept at the plain sight in the mobile backup. And in several of those, we had the user information tagged and available, okay? Some of the Amazon listings, they were just coming from, I think Etsy listings, they were just coming from AWS, so plain-sighted URLs. In addition to that, here you go. So we did identify some disturbing pictures, listings getting automatically populated because, ultimately all of these websites are using a keyword-based search, right? And then there is a ranking algorithm that is actually running behind the scenes. So based on those ranking algorithms, it is going to auto-populate, what you tend to see on the screen. And sometimes there are sponsored advertisements that actually flow in that determines what you get to see as the listing when you search for a product. It could be a pen, it could be anything, right? So we happen to have at least 3 different disturbing pictures and some of the pictures with high level of skin exposure. And this is typically what anybody would see if they are even searching for naive terms. Okay? So end of the day, we found a lot of URL cached information, and certainly none of the default settings were offering any type of privacy aspects for end users. Okay? So one of the things that we had spoken about in this research paper was how privacy implications must be standardized by these companies, by mobile commercial forensic applications. The data must be the data that's going to be available, and what the user would be viewing must be informed to the users up front. So there's something called the privacy policy information while we install an application. So it needs to be standardized, it needs to be made sensible, and it needs to have the information that we are giving up. Okay? So that's the second part. And the third part of one of the research works that we are doing is on IoT data forensics, so Internet of Things. Okay?
Smartphones, Internet of Things devices have become increasingly popular in many households, having sold millions of units since the early 2010s. The popularity of devices like smart thermostats, home security systems, and speakers can be accredited to the ability for users to monitor and control these objects with their smartphones and watches, even if the user is away from their home. Because of their constant connection to the internet, smartphone devices store data in the user's smartphone. That data is now being used by forensic investigators to solve crimes. for investigators to tap into data stored by the smart home objects, phone, and watch applications. By plugging an iPhone into a computer, the FEAAS analyzes iTunes backup data that stores the application's cache. FEAAS works by utilizing logical acquisition that creates a report of each time a user interacts with smart home instruments, what device they use to interact with these objects, and their location at the time of interaction. By using this data, investigators can create a timeline of events based on the time and location data from these Internet of Things devices.
So this is a work that's 3 years old, I believe, and the code for this software is available in GitHub. It's an open source software, so if you want to go ahead and take a look at this, right? So end of the day, what did we identify? So if you happen to have a smart thermostat in your home or a smart camera in your home, like something like an outdoor surveillance camera, right? Just by controlling such devices with your mobile phone and web applications that run on your computer, when we looked at the timeline of information and all the residual data that was just stored in your mobile phone's backup, we were able to stitch it together and produce 3 years worth of data that tells accurately when you were home, when you were out of home, when you had internet connectivity, at what time the data from these IoT devices got synced to the cloud, when it had to be queued up because you were at a location without internet connectivity, how long it was kept queued up, and everything from those thumbnails to whatever was there in the front camera's view. Okay, so some of the devices that we had used for our experiment are Nest IoT devices, so Nest camera, front door camera, indoor camera, and then we had used the Nest thermostat. We also use the Google Home Mini, so different types of ways in which all of these IoT devices could be controlled, right? The voice recordings, anything, any actions. So a bunch of data all kept unencrypted in your own mobile phone backup. So this is back in 2018. Certainly, a lot of changes have been happening to the IoT industry. There was a bill that was passed by the Congress. Measures have been taken to tighten IoT measures, and nonetheless, everyone knows this. One of the FBI offices was hacked because of a backdoor vulnerability that existed in their HVAC system. So that's how much of exposure is already present there. Okay? So if you happen to have any of those devices at your home, do a network scan, identify if there are any open ports or any vulnerable ports or any backdoors with vulnerabilities that exist in your devices. So there could be basic tools like a network mapping tool. It's called Nmap. So if any of you are using tools like Python on your machines, it's a very simple command that you have to just hit, and that's going to expose all of the open backdoors, and it'll help you secure those systems. And one of the best ways to do it is if you happen to have any of those vulnerable devices, you can just isolate it from the main network, form a different subnet, and certainly all the network geeks here, they should have more brilliant ideas of securing a network. I'm a little low in that case, but good luck to you, okay? All right, wonderful. So this is the entire system, the set of devices that we had analyzed. And without boring you too much, I'm going to get to another important slide. So this is on wearable devices. Now we have looked at various devices that are sniffing you, right? Here is another one.
One of the most popular trends in technological fields is the ability to connect everyday objects to the internet. Wearable technology such as watches and phone devices like thermostats and cameras can all be accessed on a user's smartphone almost anywhere on the planet, as long as they have a secure connection to the internet. Because of their ability to store data, smart devices are now becoming crucial evidence in criminal cases. There have been multiple cases since the mid-2010s where smart device data was used as key evidence in cases such as insurance fraud claims and sexual assaults. But while this data can be used to assist law enforcement in court, investigators now face two main challenges. First, obtaining data from many devices for a case, and second, how to analyze a massive large amount of information. current analysis tools such as data carving and command line tools are no longer adequate due to the overwhelming amount of data needing to be analyzed. The device data extraction forensic analysis model can be used in digital forensic investigation that uses automatic data extraction and a suite of integrated analysis tools to support the needs of large data forensic investigations. For example, a DEFA model can be used to analyze insurance fraud case where a trainer claims half is injured. Using DEFA, the heartbeat data can be inserted onto a timeline and show that activity levels were actually low during the claim time of injury. By utilizing several data exploration and analysis tools, DEFA can support correlating various events in order to solve criminal cases quickly.
So this is another project where we went a little beyond just the IoT devices that are hanging all over, but that's just present right in your wrist, right? So one of the devices that we looked into is Apple Watch, and then the same technology could be extended to Fitbit. Now, with your Apple Watch, again, or any smartwatch, you can control any of the IoT devices. It could be a camera, it could be a thermostat, etc., right? And since 2018, the first case from Germany, devices like wearable devices have become admissible in court, that the data that's coming from there, that could prove an incident, it could be used to solve a crime. So these are another range of devices. So the framework that we devised here, it's called DEFA. It actually combined the data that's coming from all of these IoT devices, wearable devices, and it can actually look into activity patterns at various times. If there are mathematicians in this audience, then you can actually extend beyond just forensic analysis, apply statistical measures, apply more analysis techniques to make sense out of the data. Great. So with that, here are some more exciting stuff that we are doing in our lab. We have our own set of IoT devices. We have configured, determined various different attack scenarios, classified those, and my students do more amazing work. Some of them even, I don't have to advise them, they advise me. So yeah, either way, it's good. And this is where we are getting to, where we are looking at more explainable AI techniques. Some of the projects that have been funded, trusting me. So one was funded by the National Science Foundation. The other one was funded by National Security Agency. Both of the projects have come a long way, and successful papers, patents coming out. So I'm happy, delighted for it, and I'm looking forward to an even more exciting journey in the next few years of my tenure. And, sorry, here you go. All right. Great. And with this, I will let you all take a break, okay? Yeah, I'm happy to answer any questions if you have, and I'm open for any discussions. Okay? Great. Great. So if you have any questions, DFAIR is the name of my laboratory. It's called Digital Forensics Artificial Intelligence Research Lab. Shoot any questions anytime. We'll be happy to respond. Okay? I appreciate your presence here, and you all have a wonderful rest of the afternoon. Thank you. Bye-bye.